Hello everyone, this is your Priyanshu, Assistant Professor of Studies in History. Today we will talk about soil pH, soil acidity and mining, introduction and soil pH concepts. So let's see what is soil pH. Uh, about the soil pH, some introduction. Uh, don't line to fight soil acidity, use line to feed the plant. Uh, the soil acidification means the addition of acidity of the soil. Acidification occurs naturally, but faulty agriculture practices also enhance this process. Soil pH is a measure of the soil solution's acidity or alkalinity. By a definition, pH is a negative log theorem of the hydrogen ions activity of the soil solution. Soils of a humid region and soils derived from the acidic parent material have a poor B saturation and therefore low pH. This soil are widely distributed across the global, include India. Acid soils are the less productive because of the some soil-related constraint. This are a toxicity of the aluminium deficiency. Uh, some of plant nutrients such as phosphorus, calcium, magnesium, boron, molybdenum, and a poor biological activity. It is possible to ameliorate soil acidity by the application of the lime at the time of the sowing of crops. Another option to manage soil acidity is to grow crops which are relatively tolerant and grow well under acidic environments. This in this slide has been specifically designated to provide a scientific inputs on the basic on as this. Um, term first coined and used by a Danish scientist Sorsen in 1909. Sorsen in 1909. Soil pH measured the hydrogen ions activity and expressed a log theorem at term. The practical significance of this is that each unit change of the pH means a tenfold change in amount of acidity or basicity. It is given by expression pH log theorem 1 upon a hydrogen ions is equal to minus log hydrogen ions. Soil pH determination. Soil is measured by the pH meter. The pH meter is basically in a high impedance amplifier that accurately measurement in minute electrode voltage and the display the result. directly. A glass electrode in contact with the hydrogen ions form a solution, acquires an electric potential which depends on the concentration of the hydrogen ions. This is a measured potency, potential metrically against a reference electrode, which is usually a um, uh, calomel electrodes. The potential difference between a glass and calomel electrode expressed as a pH. The electrode consists of the mercury in the contact with the solution of a KCl saturated with the mercurious chloride. Mercurious chloride. It maintains a constant potential at a given a temperature in the commercial models based of the um, mercurious and mercurious chloride is connected in an inner tube contact connected to a KCl in outer jacket. A lead virus is connected on the mercurious chloride passed through the column of the mercury. The outer tube ends in a fine capillary to provide a salt bridge through the test solution to the glass electrode. pH meter with a combined electrode is available in a digital type instrument. The description of the electrochemical cell used for the measurement of the soil pH. Uh, for a pH and pH meter is calibrated by the standard buffer solution. Standard buffer solution of pH 4.0 and 7 and 9.2. The step followed for a pH measurement, like first one at 10 gram air, 10 gram and air dry soil transferred a 100 ml beaker in the 20 ml 25 ml distilled water added. After that, the contents are stirred intermediately using a glass rod, and it's allowed to stand for 30 minutes. The pH meter is put on the calibrate with the help of a buffer solution. The suspension is tried just before taking the reading. The electrode is immersed into the beaker connecting soil water suspension. The read button to press. The meter reading is noted. This gives a pH value of the soil suspension. Some important point here: the pH of the soil suspension varies with its water content. The pH of soil suspension is always low than a pH of the supertenant liquid. Uh, 1:1 soil water paste may have a pH 1 unit or more lower than a 1.5 or lower water suspension. Generally, pH is measured in a soil water suspension. In soil testing laboratories, 1:2 or a 2 ratio to 1 ratio 2.5 ratio is used, but is in a salt affected soil salt affected soil and dilute salt solution KCl and calcium chloride is used in a place water. The dilute salt is used to mask the effect of a naturally working soluble salts on a pH measurement. Now, most important topic here, buffering, and it's important. Soil tends to resist a change in the pH of the soil solution when either acid and basis is added. This resistance to change is called a buffering. Soil behaves like a weak acid that will buffer pH. In acid soil, absorbed aluminium in equilibrium with the aluminium in the soil solution. The aluminium ions are hydrolysis produce hydrogen. If hydrogen is neutralized by a base, for example, calcium carbonate, aluminium is in the soil solution precipitate the aluminium oxides. Uh, Causing exchangeable aluminum to absorb to resupply solution aluminum. The soil pH remains the same or a buffered as more calcium carbonate is added. The reaction continues with the greater replacement of the calcium for exchangeable aluminum. As a result, the pH gradually increase. The buffering capacity reliance of soil response of hydrogen concentration increase as cation exchange capacity increase. The soil connecting a higher amount of the clay and organic matter exert a high buffering capacity and require a high amount of the lime increases on the soil pH. Then a soil with a lower buffering capacity also the soil with a dominance 1.1 clay minerals or a less buffered compared to the 2.2 ratio 1 clay minerals. In other words, the buffering capacity depends both on the size of the cation exchange capacity and on the extent to which it is saturated with cations other than hydrogen ions. Buffering action is effective in controlling soluble concentration of the ions such as hydrogen, aluminium, calcium, magnesium, potassium, sodium, etc. The degree of a buffering is the highest uh, between 4.5 to 6 point and the drop below 4.5 and above 6.0. Soil having an equal base saturation will have a highest pH associated with the hydrous oxide clay minerals and the lowest in the 2.2 ratio 1 types of the aminosilicates clay minerals. However, pH are intermediate in the soil dominate on kaolinite and humus. Buffering is important for two reasons. Buffering tends to ensure some stability in soil pH, preventing drastic fluctuations and that might be harmful for a plant microorganism and the uh, aquatic ecosystem. This is also likely to reduce the adverse impact of the soil pollution, acid rain and the or a continuous use of the acid forming nitrogen fertilizer. So second one is a buffering influence the amount of the abatements such as a lime in an acid soil or a sulfur gypsum or a alkali soil required to bring about a desired change in the soil pH. Soil pH and the nutrient availability. Soil pH and nutrient availability. Soil pH is the master available master variable influence the availability of the plant nutrient. Soil pH has a both direct and indirect effect on the toxicity of some metal ions like iron, magnesium, aluminium, etc. Deficiency and reduced availability of calcium, magnesium, and phosphorus, boron, and molybdenum, and the decreased soil biological activity. Rhizobium, mycorrhiza, fungi, and the other microorganisms. The availability of phosphorus as H2O, PO4 and HP2O4 ions is a higher pH depends. Its availability in a many soil is a high when a pH is a neutral and slightly acidic. That it is decline the soil becomes either strongly acidic and moderate alkaline. The availability of the micronutrient present in the cationic forms such as iron, copper, magnesium, zinc increases at a low pH acid soil. Increase at the low pH acid soil where the availability of those present in the ionic forms of the namely molybdenum and boron exhibit and the reduction in their solubility and the consequently availability. Generally, bacteria actinomycetes are active in a madly acidic neutral and the high pH as well. Fungi function well in the wide range of the pH predominating in a acid soil as a compared to intermediate at a high pH. Bacteria such as a rhizobium in a leguminous involved in atmospheric dinitrogen fixation are less effective in the mm, uh, acid soil. Bacteria responsible for the conversion of a nitrogen and sulfur etc. from organic and inorganic form and less active in the soil pH, low pH soil. Now acid soil. Soils are distribution, classification, and characteristics. So, acid soil are formed mainly due to a leaching of bases, weathering of acidic rocks, and the mineralized parts and sheets also result in the formation of acid soil, a degree of acidity. The degree of acidity indicated by the soil pH. Extremely acidic soil pH range is more than 4.5, very strongly acidic 4.5 to 5, and strongly acidic 5.1 to 5.5, moderate 5.6 to 6, and slightly acidic 6.1 to 6.5, and neutral 6.6 to 7.3. Is soil pH determined by the soil forming factors such as rainfall, in temperature and vegetation, parent rocks, and the hydrological condition. In India, acid soil comprise about a 28% of the total geographic area. Out of the 9.3 percent are strong to moderate acidic pH 5.5, while 18.9% are slightly acidic pH 5.5 to 6.5. These um, soils also distribute in the Himalaya region, the eastern and the northeastern plains, and uh, Peninsula Indian and the coastal plains under a varying agroclimatic conditions, such as the soil occupies about 90 million hectare, about the total geographical area, out of which 50% is under cultivation. The rest in the under the forestry and other use. About 30 million hectare of the cultivation. Land with a pH less than a 5.5 is critically degraded with major soil related constants leading to a poor crop production. To the degraded area in Chhattisgarh and the Arunachal Pradesh is a predominantly mm, uh, dominantly under a forest. About 21 million hectare of acid soils are found in the northern eastern hill region, including a Sikkim. Acid soil of a Himalaya region extend from Kashmir in the northwest to Sikkim, Arunachal Pradesh, and other state in the north east. With wide variation in the micro and the macro climatic physiography and vegetation among the soil grade groups, and the astrodepts and haploids and the haplum breadbirds in the eastern and northeastern Himalaya, while agri-dolls are the predominant in the western Himalaya. Acid soil are the peninsular Indian are the distributed in is almost all the states except the western state, which where rainfall is low. Red and the lateric soil are the peninsular Indian are the distributed in the state of the Kerala, Tamil Nadu, and the Karnataka, and Andhra Pradesh, and Telangana, Madhya Pradesh, Chhattisgarh, Maharashtra, Goa, Odisha, West Bengal, and the Pondicherry. This soil have developed on the granite and the uh, genesis and the ferrogenesis sandstone and the schist of the Archean period. Among the soil haplosalt and the haplosteps and the ostrothins are the common. Acid soil is the eastern plains are the distributed in the Assam Valley and to some extent in the Jharkhand, West Bengal, and the Tripura and the lower Gangetic plains. These have been classified and the occupied and the Adifluent ST Asti Astipasments acid soil of the eastern coastal plains of the Andhra Pradesh, Odisha, Pondicherry, Tamil Nadu, and West Bengal have developed and on a sandstone. These soils are the classified as the cultivated for a rice or a coconut. Acid sulfate soil coastal area plains and occur in Kerala in the west coast deltaic area of Sundar Bens in the West Bengal and some pockets of the Tamil Nadu. In a soil under a tidal influence, the reaction of a sulfuric acid with iron bearing minerals yield a basic iron sulfate called jarosites. which is present in the most of the acid sulfate soil vegetation and the Sundarban areas is the and the mangrove swamps. The soil of the coastal and the Iceland ecosystem are the classified as the sulfur cupids. The feature of such low pH soil have been discussed earlier. Acid soil are the base unsaturated, and therefore are poor in calcium and magnesium, but have a high concentration of the iron and aluminium. So the soil suffer from the deficiency of several essential plant nutrients such as phosphorus, calcium, magnesium, molybdenum, and boron, and often toxicity of the aluminium, especially in the soil pH less than 5.0. Fertilizer used in the acid soil region is limited, often due to a rainfall cultivation, poor crop yields. The soil occurring a hilly trains and a high rainfall region cause a problem of the high soil erosion and the land degradation. In many areas, poor soil physical condition, light action, low water holding capacity, calionitic clays, and the poor biological property due to organic matter content create a problem for a successful crop production. Chemistry of soil acidic, the forms of the soil acidic, there are three major forms of the acidic, namely active acidic, exchangeable acidic, and the reserve acidic. If we add all the three forms, it continues constitutes the total acidic of the soil. Are less common from, but sometimes very important in the potential acidity, which are arise upon the oxidation of the sulfur and the compounds of certain acids, sulfate salt. Active acid is due to a hydrogen ions in the soil solution. This pool is a very small compared to the acidity in the exchangeable and the residual pools. Active acidity is extremely important because it determines the solubility of the many substance and provides the soil solution environment to each plant roots and the microbial and the microbes and the exposed exchangeable or a salt replaceable acidity. It is a primary associated with the exchangeable aluminium and the hydrogen ions that are the present large quantities in a strongly acid soil. Their ions can be released into the soil solution by a certain exchange with unbuffered salt, such as a KCl as per the exchangeable acidity is a very high in a soil with a moderate and strong acidity, and is difficult to neutralize at a given pH. Exchangeable acidity is generally highest for cementites and intermediate for the vermiculites, and lowest for kaolin. Residual acidity is generally associated with the hydrogen and aluminium ions, including aluminium hydroxy ions that are the bound in the non-exchangeable form by the clay and the organic matter in the soil. As the pH increase and the bound hydrogen dissociated and the bond aluminum ions are released, the precipitate as amorphous aluminum hydroxide. This change free up the negative cation action site and increase the cation exchange capacity. The reaction with the calcium Calcium hydroxide oxide shows how the bond hydrogen and aluminium. This residual acidity is commonly far greater than the active and exchangeable acidity. It may be 100,000 times greater than the active acidity in the sandy soil, and the 5,000 for even the 1 lakh times greater in the clay high soil, high in the organic matter. Thus the total acidity is equal to acidity active acidity or a salt replaced salt exchange acidity plus a residual acidity. Beside the three poles of the acidity, a large pool of the soil acidity may occur in the soils or the sediments that contains reduced sulfur. If a drain If a drained excavations or another disturbance introduce oxygen into this normally anaerobic soils, oxidation of the sulfur may produce a large amount of uh, acidity. The term potential acidity refers to the acidity which could be produced by the such reaction. The acid sulfate soil contain iron sulfide minerals in the undisturbed state. They remain waterlogged and the harmless, but if due to a drain air entered into the system, then both the sulfur and iron are oxidized, changing the potential acidities as acid sulfate soil to active acid sulfate soil. Ultimately, such a soil produces large quantities of the free sulfuric acid, which bring down the pH to a 4 or less. This subsoil acidity in a some acid soil, it means a alti soil. The acidity extend down the profile into the subsoil, increase the subsoil acidity depends on the leaching of the hydrogen and aluminium ions from the surface horizon. Counter ions of the anions root growth in the often limited of the surface horizon such soil due to a soil acidity. Liming to neutralize the surface soil acid in this soil has a little effect on the subsurface acidity because a bulk of calcium ions remain in the surface horizon. Research has shown that a surface application of the calcium sulfate can ameliorate soil acidity. Limited retention of the sulfate ions in the surface horizon provide the mobile ion for the motivation of the calcium ions into the subsoil. The net result in an increase in the exchangeable calcium at the expense of the each aluminum. Lime potential measurement of the soil pH can give a variable result because of it is affected by the suspension effect, the soil water ratio, and the electrolytes level. Uh, Schofield and the Toiler in 1955 proposed the use of 0.01 molar calcium carbonate, calcium chloride, and KCl solution for the obtaining stable reading in the pH measurement. This scientist suggest that they insist over using a single ion activity hydrogen measurement. It is better to use the ion activity ratio. Ion activity ratio, also known as a hydrogen hydrogen upon calcium for a determined determination of soil acidity and base saturation. If the soil exchange complex is saturated with the both hydrogen and calcium ions, then the equilibrium as per um, Schofield or ratio law, hydrogen ions upon under root calcium is equal to constant T. Role of pH half phosphorus calcium is termed as the potential. It is characterized as the composition of the exchange complex with respect to the its saturation via hydrogen and calcium ions. Many methods for the determination of the lime requirement take into the consideration the lime potential. Role of aluminium in a soil acidity. Aluminium is a problem in a acid soil because it is soluble at a low pH. This is also true for iron and Manganese. Aluminium is a component of a clay. Aluminum is a component of a clay. As the pH decrease and concentration of the aluminium in the soil solution increase due to a dissolution of aluminum hydroxide. So at a low pH, the equilibrium shift to the right, where aluminum hydroxide dissolve the produced aluminum, which can then be absorbed uh, onto the exchange complex, depending on the pH. Aluminium hydrolysis to produce a hydrolytic species in a strongly acid soil. Soil's hydrogen ions active in a soil solution is a very high, but absorbed hydrogen is less. Aluminium to convert to aluminum hydroxide ion. Some of these aluminum hydroxy ions are absorbed at as exchangeable ions. This remain in the equilibrium with the aluminum ions in the soil solution. In the soil solution, these hydrolyze and produce a hydrogen and thus contribute to soil acidity as per the following. Aluminum hydrolysis will buffer the increase in a solution pH 5.5 is the reference point. Above this, no exchangeable iron aluminum remains associated with the soil clay irons. Uh, Hydrolysis reaction. Thus, iron hydrolysis does not affect the soil pH. Till most of the aluminum has reacted at a pH below 5.5. Iron behaves like aluminum, but acidity greater by iron is much less than that by aluminum. And the relationship between pH and dissolved magnesium is similar to the aluminum. As the pH drops from a 5.5 to 4.5, dissolved aluminum is a thousand times greater at the pH 4.5 than at the pH 5.5. The dissolved magnesium, on the other hand, may increase 100-fold with the drop of the pH from the pH 5.5 4.5. The level are greatly affected by oxidation and reduction condition of the soil. Factor for developed of a soil acidity. Acid soil are formed mainly due to acidic parent material and the leaching of a base caused due to a high rainfall. Acidic granite rocks as parent material and the process of the soil formation render the soil acidic. Use of the acid forming fertilizers such as ammonium sulfate or urea in the soil create a soil acidity. Calcium and other basic elements are displaced by a ammonium ion leading to the formation of the calcium sulfate, which is the leachable. The removal of base from the soil takes place due to a two process. Uh, Leaching, loss of the basic cation and the removal of bases from soil due to a cropping, rapid movement of rapid movement of excess water through our soil in a high rainfall areas plays an important role in acid soil development. The reason with the annual rainfall of 1350 mm have a acid soil with a pH value uh, 5.0 or less. Microorganisms are responsible for the decomposition of organic residues. Organic acid formed during this process are neutralized by the basic ions such as calcium and magnesium, etc. So, if base saturation is low, generated are not neutralized. Carbonic acid is formed by the action of the carbon dioxide and the water. The solvent action of a carbonic acid remove a base forming cation like calcium and magnesium. In the coastal and the marshy areas, dense vegetation is accompanied by a high rainfall and the waterlogging. Under such a situation, materials do not get enough oxygen to decompose completely. This gives rise to a soil acidity. True,